Okay, so now that you've developed your statement of inquiry, usually the next part, you don't have to follow the specific order, but it's a good idea to create your summative. So the IB does not expect students just to kind of recall mathematical information. There's 4 different types of criterion assessments that can be used in mathematics, and they unoriginally called these criteria A. Criteria A, which is knowing and understanding. That's as closest to a traditional test as you'll get with the IB. Criteria B, which is investigating patterns. Students have to manipulate patterns and form general rules. But what I'm going to talk about today, because that was the assessment that I used for my unit, it's called Criteria C, communicating, and Criteria D, applying mathematics in real life situations. So I actually took those 2 criteria and combined them to make an assessment for the unit. So I'll discuss that more. So if you want to see the assessment criteria for your content area, there's always 4 for whatever content area, just like how there is in math. I recommend reviewing the MYP DP guides that I uploaded for you. Take a look at the assessment section and you'll see the criteria for your assessments. Assessments are scored out of 8. They're divided into 4 mark bands as well, and each criteria is expected to be assessed twice in a year. So again, I'm going to specifically discuss criteria C, communicating, and criteria D, applying mathematics in real life context, because these were the criteria that were most foreign to me when I started instructing in the IB. So I'll explain the criteria to you, then I'll explain the assessment that I used in my unit against the criteria. So here's criteria C, communicating. There's 5 different strands, so 5 different characteristics that I need to assess when the students give me their product. So the first strand is use appropriate math language in oral and written explanations. So it could be either or both. Use appropriate forms of mathematical representation, so that's showing graphs, tables, and charts, and showing it effectively. Moving between different forms of math representation, so maybe students make a function and then they draw a graph of that function. And then communicate. So communicate using complete lines of reasoning, mathematical lines of reasoning, so that could be a string of equations, or just explaining mathematics clearly. And then organizing information using a logical structure. So there's a nice flow when the students organize information. Then criteria D, applying math in real life context. So that's the first strand is identifying relevant elements of an authentic real life situation. The next strand is selecting appropriate math strategies when solving authentic real-life situations, and applying the selected mathematical strategies successfully to reach a solution, justifying the degrees of accuracy of a solution, and then justify whether a solution makes sense in the context of the authentic real-life situation. So there's a lot there within those strands, and a lot to look at. Criteria D is about mathematics in real life. Applying math. So how can mathematics help generate a solution given a real life situation? Some teachers incorrectly try to create an artificial context, such as a story or a word problem that it's a multi-step word problem that students solve, but that doesn't have authenticity. It's not a real life situation. They need to engage in it. So that's the key word there. It's authentic. Students need to do, so in my case, I think it's best if students can do some sort of activity. They can collect data and they can analyze the data, and that's what I did in my assessment. So like I said, I combined these 2 criteria. In my case, students completed a project-based assessment on periodic phenomena. That's data that repeats itself. So for example, the tide waves. Every day there's high tide, and then time goes by, there's low tide, and then time goes by, there's high tide again. Well, that forms a wave if you graph that. And in math we call those sine waves or cosine waves, what have you. But students had to collect the data and be able to model that data using these functions, these sine functions. If I pick apart criterion D, applying math in real life context, so let's take a look at strand 1. At least for my students, they had to identify data that was indeed turned out to be periodic. That was the idea. They had to identify periodic data. Strand 2, to select appropriate math strategies, in this case, had to apply trigonometry, specifically these types of ways that I discussed with you about. And then part 3, they had to determine a function. They used they actually used technology to determine their functions. I was totally okay with that. And then they had to show a graph of it, for example. That's for criteria C. Now, part 4, justifying the degree of accuracy of a solution. They had to determine how accurate their function was against the actual data that they recorded. And then they had to make sense of their findings. Could they make accurate predictions with their functions, for example? And that was a quick rundown of my assessment. I know there's a lot more details that I could share with you with it, but please take a look at it. I uploaded it for you guys to see, to get an idea of what the assessment looked like.